Okay, so welcome to Unit 3, Lesson 2. So in this lesson, we're going to be exploring arithmetic sequences, and our learning goals are to use a formula which represents the general term, identify the first term and the common difference, find a formula for the general term, and to be able to find the nth term of the sequence. So since this is our first introduction to arithmetic sequences, it's really important to familiarize ourselves with the characteristics and the properties of an arithmetic sequence. So first of all, a number sequence is any pattern of numbers that follows a rule. So we're going to learn about arithmetic sequences this unit as well as geometric sequences, but this video in particular is about arithmetic sequences. So in particular, a sequence of numbers is usually a list, and that could be a list that ends, that is finite, or a never-ending list, which is infinite. And that list is arranged in an order that obeys a certain rule. Each number in the sequence is called a term. So terminology is going to be really important for this. So that's very general, just about sequences and their properties. There's certain properties that are very specific to arithmetic sequences. So in an arithmetic sequence, what happens is that you find each term by adding or subtracting the same number to the term before. So that's what makes it arithmetic. You're constantly adding. And I actually think it's easier to think about adding a number rather than subtracting. Just think that that number that you add could be a positive number or a negative number. So the arithmetic sequence you get could be an increasing sequence or it could be a decreasing sequence. So basically it goes up or down in equal size steps. And that step size, or the number that you add each time, is called the common difference, and we represent that with the letter D. Also important is the notation we use for the terms or the values in the list. So the first term is written as U1. All subsequent terms follow the same pattern. So if U1 is the first term, U2 is the second term, U3 is the third term, and so on. So we have three examples of sequences here, and for each one we're going to identify U1 and D. So in the first one, U1, which is the first term in the list, is 2, and the common difference we can see we're adding 2 each time, so our common difference is 2. The next sequence, our first term is 3, so that's 3, and then we're adding 0.5 each time, so our common difference is 0.5. In the last term, you'll notice our numbers are getting smaller, not bigger. So we start with 1, and at each step, what's actually happening is we're subtracting 3, or adding -3. So our common difference here, the sign is really important, the common difference is -3. So it's going to be really important to be able to identify those properties in these patterns, because those properties will be used in the formulas that you'll be applying. So in any arithmetic sequence, you end up with this pattern that you see here. So U1, to get U2, you take U1 and you add D once. To get U3, you take U2 and you add D, to get U3, you take U2 and add D, which is the same as taking U1 and adding 2D. To get U4, you take U1 and you add 3D. So you're always taking U1 and adding one fewer D than there was in the term you're looking for. So if you're looking for term 4, you only add 3D. So if we translate that into a formula, this is what you get. So the general term of an arithmetic sequence can be represented by this formula. And if the common difference ever isn't apparent to you just by looking at the sequence, you can always find the common difference by subtracting one term from the one that follows it. So you're going to subtract U1 from the next one, which is U2. And the common difference is always the same because it's an arithmetic sequence. So it doesn't matter whether it's U2 minus U1 or U3 minus U2, you'll always get the same answer. So I think the key thing now is to actually start working through some examples. So First example, we have a sequence of numbers given. The first question is asking us to identify the first term and the common difference. So this we can tell just by looking. U1 is 2 because that's the first thing we see in the list. And D is 3 because at each step from one term to the next, we are adding 3. So for the 10th term, we're going to use the general term formula. And I'll just remind you that it's UN equals U1 plus n minus 1 times D. So it's really important here to be able to distinguish between n and un. So u1 is 2, but for this term, n is 1, because n is where it falls in the list. So for the second term, u2, which is the second term, is 5, but n for this term is 2, because it's the second one in the list. For 8, u3 is 8, n is 3. u4 is 11, n is 4. So it's really, really important to grasp the distinction between n and un, because if you don't, you might put the numbers in the wrong place in the formula. So if we're looking for the 10th term, that means we're looking for u10. And since we're looking for the 10th number in the list, we're looking for the situation when n equals 10. So oftentimes when I'm doing these kinds of questions, I'll just make myself a little list off to the side. So I know U1 is 2. I know D is 3. I know N, in this case that I'm interested in, is 10. And UN, or U10, I'm not sure. That's the thing I'm looking for. So one thing that's helpful to keep in mind is that whatever N is in the order of the list, you just replace that with the N in the UN term. They're always the same as each other. So because N is 10, I'm now going to change this to say I'm looking for U10. U1 is 2, N is 10, and D is 3. So U10 is 2 plus 9 times 3. That's 2 plus 27, which is 29. So the 10th term in the list, if I were to extend this list, would be 29. And then it's asking us for the 25th term. So I'm going to start with the same formula, because again, I'm just looking for another value in the list. But the place order of that value in the list that I'm looking for is now place 25, the 25th number in the list. And that place, or that value, not the place order, I know the place order, that's 25. The value of the number that occupies the 25th spot is ultimately what I'm looking for. So that's U25 that I'm trying to find. U1 is 2, N is 25, and D is 3. So that means I have 2 plus 24 times 3, which is 72, which means U25 is actually 74. So that's how you apply the general term formula in the most straightforward way. When you're looking for a particular value in the list, you know what place it occupies, and you just apply the formula. Sometimes you will be asked to apply that formula a little bit differently. So here's another example where you're given a sequence. You're asked first to find the common difference, and second to find the number of terms. So let's start with part A. Anytime it says find, that's an indication you need to show work. It doesn't have to be a lot of work necessarily, but you do need to show a method for how you figured that out. So D is going to be equal to U2 minus U1. So that's 10 minus 6, which means D equals 4. So it's pretty straightforward calculation, but you still need to show your work. Now, this is a situation where we're kind of in the opposite situation we were in the first example. In the first example, we were given the place order and asked to find the value. In this sequence, because it's asking for the number of terms in the sequence, we need to know what place order this value falls in. Because we know this is first, we know 10 is second, we know 14 is third. What is 50? So really what we're looking for here is we're looking for n. That's our goal here. Instead of looking for un, we're looking for n. So again, we're going to use the same formula, but we're just going to be looking for a different value in that formula. So I'm going to start by writing down the formula, and again, making myself a little list of what I know. So U1 is 6, D is 4, N this time is unknown, I don't know that, but UN, which is the value of the nth thing in the list, or the last thing in the list, this time is 50. So based on that, I'm now going to substitute in what I know and do some algebra to figure out the rest. So UN this time is my known. I know the value of the thing in the list, I just don't know where it falls in the list. So U1 is 6, N is unknown, and D is 4. So whenever you're solving, you kind of want to work from the outside in. So I'm going to get rid of the 6 first, which means I'm going to subtract it from both sides and get 44. And then what I can do is I could distribute the 4. I could also just divide by 4, because 4 divided by 4 is 1. Do the same to the other side. And I get 11 equals n minus 1, which means n equals 12 when I add 1 to both sides. So therefore, there are 12 terms in the sequence. So that's an example where you're still using the same formula, you're just searching for or solving for a different variable in that formula. Okay, so here's another example. Sometimes you'll be asked to find a formula, not a number, but a formula for the general term. In that case, you start with the general term formula, you sub in what you know to be true, and you simplify as much as you can. So UN, we don't replace that with anything because we're looking for a formula to be able to find UN. U1 is 2. We don't know anything about N, and we know that common difference here is 7. So D is 7. So all I'm going to do here is I'm going to simplify that equation by distributing the 7 through the brackets, and that simplifies down to 7n minus 5. So that's just a simplified version of the general term formula for this particular sequence. It only applies to this sequence because it only applies for a sequence where the first term is 2 and the common difference is 7. So now that we have that, we can actually use that formula we just created to solve part B. So instead of starting with a more complicated general term formula, I have a simplified version that I can use to solve the problem. So what it's asking for here is whether 2,341 is a term that will occur in the sequence. So if I continue this list for a very long time, will I ever write down the number 2,341? So basically what this is asking is when UN is 2,341, is n a whole number? And that's because in order to be a term in the sequence, you have to have a proper place order, like first, second, third. You can't be in place 1.7 or place 2.3. So the n values have to be natural numbers or positive whole numbers. So that's what we're really trying to find here. So we're going to replace UN with 2,341, and we're going to solve for n and see what happens. So when we add 5 to both sides, we get 2,346. And when we do 2,346 divided by 7, we get n equals 335.14. And it's good to not round to 3 sig figs here because we need to show that this is not a whole number. So therefore, 2,314 is not a term of the sequence. And we know that because n was not a whole number there. So the last example is a really common question where you're asked, you don't know either U1 or D, and you're asked to find both. And this is something you do with an app on the calculator. So I'm going to take this opportunity to sort of walk you through how to use that app. So in a question like this, you're given two pieces of information. The fifth term is 20, and the 12th term is 41. You don't know anything else. You don't know U1, you don't know D, and you're asked to find both of them. So there's a couple of ways you could do it. I'm going to show you using the app first, and then I'll show you an alternate method. So the first thing you need to do when you're using the app is you need to make two equations for, or in terms of your two unknowns. So I'm going to base my equations on the information given about the fifth term and the 12th term. So U5, based on the general term formula, U5 is going to be equal to U1 plus N. In this case, because it's the fifth term, it occupies the fifth place. So N is 5 minus 1 times D. So, but I know the value of the fifth thing in the list, and that value is 20. So I can replace U5 with 20, and I get U1 plus 4D. That's my first equation. The second one is going to be based on the second piece of information. For U12, the 12th thing in the list, N will be 12 because it occupies the 12th spot. And then if I simplify this and sub in what I know about the 12th term, the fact that it's 41. So again, N is 12 because we're talking about the 12th thing in the list. UN, or U12, is the actual value of that 12th thing, which is 41. So this becomes 41 equals U1 plus 11D. So now that we have these two equations, we can solve for U1 and D simultaneously using an app on our calculator. So what you're going to do is you're going to press apps on your calculator, and then you're going to go to the one that says PolySmilt 2, because it's the polynomial simultaneous equation solver. You're going to press any key as it tells you to continue, and then you're going to pick option 2, which is the simultaneous equation solver. When you pick that option, you're immediately going to go next. You're not going to change any of those defaults, and you're going to select next by just pressing the button right underneath where you see it say next. So that turns out to be the graph button, and you're going to go here. You're presented with a matrix. What the matrix is really asking for is that you have the coefficient of U1, the coefficient of D, so you have something U1 plus something D equals something. Something U1 plus something D equals something. This vertical line here is like the equal sign in your equations. So you kind of just have to sort of flip your equations for yourself from left to right, and you might want to write that down. So just instead of reading it as 20 equals U1 plus 4D, read it as U1 plus 4D equals 20. And you can do the same for the other equation. And what you're going to type into this matrix here is actually the coefficients that you see, or the numbers that you see, not the variables, just the numbers. So if you don't see a coefficient in front of U1, it's actually there, it's just a 1. So it's a 1 in front of U1, a 4 in front of the D and the 20, and a 1 in front of the U1, an 11 in front of the D, and a 41. So when I do that in my calculator, I'm just going to type that in. 1, 4, 20, and that will be one of my rows. 1, 11, 41. That will be the other one of my rows. And then you'll see at the bottom right of the screen, it says solve. Again, press the button right underneath that, and it gives you a solution. In this case, x1 is the first coefficients you entered in each line. So that was the u, the coefficients for u1, which means u1 is 8. And d, which are the second coefficients you entered in each row, is 3. So you can solve for u1 and d just by writing two equations and then solving them on your calculator. So you use your GDC to find those answers. There is an alternative, and that alternative is to find the common difference by thinking to yourself, okay, the value difference between U12 and U5 is 41 minus 20, which is 21. In between 5 and 12, so if you think about the term numbers or the placements, so 12 minus 5 is 7 steps. So what we're really figuring out is that we account for 21, a difference of 21 in our values, and that difference of 21 is spread out over 7 steps. So our common difference is going to be that difference of 21 equally spread amongst those 7 steps, which means our common difference is 3. Once we've done that, we can use either piece of information, for example, U5, to solve for U1, because we know that U5 is 20. We don't know U1, but for U5, n equals 5, and we just figured out with our difference of 21 spread over 7 steps that our common difference is 3. So we get 20 equals U1 plus 4 times 3, which is 12, which gives us U1 equals 8. So either one of these methods will work. Calculator can be quite efficient if you know how to set up the equations. This perhaps requires a bit more thought about how to apply the properties of an arithmetic sequence, but will also work. So these instructions are for the calculator part. This one is kind of strictly algebraic, but either one will get you where you need to go. And once you have U1 and D, you can do part B, which is asking you to find the 84th term. So 84th term is U84. So I'm just going to make my little list here. I have U1 equals 8, D equals 3, N in this case, because we're looking for the term that will be number 84 in the list, that's N. UN is our question mark. So UN equals U1 plus N minus 1 times D. U84 is what I'm going for here. U1 is 8, N is 84, and D is 3. And then what I get there is 8 plus 83 times 3. Oops, I have to quit out of this. So 83 times 3 is 249. So U84 is actually going to be 257. So therefore, the 84th term is 257. So hopefully this has helped you familiarize yourself with the properties of arithmetic sequences and how to problem solve anything related to the general term, the first term, or the difference.